Hello, this is going to be a tutorial for the Heise method. So the Heise method is a method with the main selling point of being incredibly efficient and using virtually no algorithms. However, because of this, it is incredibly hard to master. While I do not claim to have this mastered, I feel I am qualified enough to give a basic tutorial. So the idea behind this method is that we reduce the cube very quickly to different states. So the first step of the method is that essentially we want to build 4 2x2x1 blocks like this all around the cube. And we want to connect them all while solving edge orientation all at once. And then after this, we want to solve all but 3 corners on the cube. So I'm going to do this as fast as I can here, just to speed things up here. Okay, and then we're left with essentially 3 corners left on the cube. 1, 2, and 3. It's at this point that you usually will just do a commutator, and by usually I mean you always do a commutator to solve it. Now, as I said earlier, this has virtually no algorithm, so how do you do that without a single algorithm? And that's the thing, you don't. At least not right away. You may learn it as algorithms to begin with, which can help, as long as it helps you understand how the cube works and how you can make those algorithms yourselves, then it makes it much easier to do this. So, the squares. How can we go about this? I personally like to solve just one edge. And there's a 2x2x1 block right there, one solved edge. But it's not truly a 2x2x1 block if you look at it. But at the same time, it is. See, if you think about it, where the core of the cube is, inside here, where all the center pieces connect, that's essentially a 1x1 block in there. Something that makes it a 2x2x1 block, essentially. You have 2x2, if you look at it this way, and then by 1. So it's still technically a 2x2x1 block. And I like to put that in the back, just for why not? And then next, I'll solve another one next to it. Because again, why not? And then I like to solve, again, one more. And again, it doesn't matter how you do this. You don't have to. You can join them right away if you want. It makes it easier for you to look at right away, but I recommend against that. But then afterwards, you want to solve again one more block, and when you have one left, that's where it's the trickiest. At least in my opinion. But so then here we go. I solve one more, and I place these, and then I'm gonna solve edge orientation while doing this. Which again is where it can get tricky. But so there we go. I've done edge orientation while placing. Now the next step is to solve all 5 edges and 2 corners. This is probably the hardest part for beginner to grasp. Now, there are 3 main ways to go about this. You can solve all your edges and then do the corners with a commutator, or with a couple commutators, which is the least efficient, but it's also the easiest. So that would look like something like this, where I solve all my edges, and then I would use commutators to solve it. The next one is to solve pairs, which is what I actually did in the first, when I was just doing a quick thing. You solve a pair like this, and then you're going to solve another pair similar to that, in some way, shape, or form. And then you would solve that. Like so. You would do something like just like that, per se. Then you would solve it. Just like this is going to scramble the last slot here really quickly. Okay. And the next way to do this is to just solve it as 2 pairs, or as 1 pair, all in one. The best way to do this is usually when you have one corner solved, or will be solved very, very quickly, and very efficiently. This is the hardest one to do, and I personally cannot do it with absolute ease quite yet. I can't do any of the other ones except for the first one, which is just the solve the edges and the commutator with perfect ease. However, the second one's also easy enough that I can do it in speed solves should I need to. So the second one is essentially you're going to do your best to solve, as has been said, pairs again. But this one you essentially solve your second pair while you would be solving you solve your second pair while you would be solving all your edges while in placing your first pair, which would give you said L3C case, like so. So then once you've achieved L3C, it's not always going to be in the top layer like this. You'll always have to solve F2L. Sometimes it'll be, as I showed earlier, it'll be something like potentially this, potentially you'd have your first slot wouldn't be solved, and you'd have corners like this, just something like that. But, so, how do you come up with a commutator on your own? That's probably the hardest part about this, is learning how to make commutators on your own. They're tricky at first and slowly come more naturally, and you can actually come up with some pretty good ones on your own. There's an easy way I've found to describe how to do commutators, and the best brief explanation I can do is to describe it something like this. So, a commutator for corners is almost always going to be a 3-cycle, unless you can come up with some commutator to do a pure twist or something along those lines. But very rarely can you come up with one of those on your own very easily. So the way I look at this is I would notice that, oh hey, this is a 3-cycle. Okay, where do the corners need to go? Well, I'm going to look back here. This is U, B, L. U belongs in F, B belongs in D, and L belongs in R. So FDR. UBL to FDR. Okay, so I can do that with RU2R prime. But I've just messed up so much. Let's look at this real quick. Now, where does this need to go? But keep in mind, these swap with the letters. So UBL, FD, or FDR. U is going to go to F, B is going to go to D, and L is going to go to R. We see that. But where does this go? FDR. Belongs in LDF. Okay, so now we know where everything needs to go, because we know that by moving this to here, if we were to keep everything else solved, this must end up here and solved, unless we somehow twist something else. So if we now do the RU to R prime to solve this corner here, we need to then look at what we can do to make it so that we can get FDR to go to to LDF. Now if we do a U prime, that does not work because we've essentially broken what we just got done doing down here, and that does not help getting that edge or that corner into place where we need it to be. So we can undo. So we're going to do our first move. So right away we know that we're going to undo RU to R prime. So we know this needs to end up here. So we can just, because we know it's going to go UBL goes to FDR. We can move this over, which then moves it from LDF to FDR. Now we can undo our first setup and undo our second setup. And that is the form of a commutator, is A, B, A prime, B prime. So in this case, our A was RU to R prime, our B was D, RU to R prime is A prime, and D prime is B prime. That's essentially the basics of commutators. You should be able to figure out most commutators on your own. There are some tricky ones. They require some setup moves, such as perhaps this one here, just as a theoretical one here. So what we could do for this one is this is the exact same commutator as I just did, but with a trick to it. So I'm going to do this inefficiently. I'm going to do it so we can get a setup idea. So I'm going to do it from here. You know it's not how you would end up with Heise, because this is down here, but bear with me for this. So I would notice I can insert this here. But then if I were to do that D2 to insert this to here, well, it's going to be twisted. So that's not what we want. We don't want that. Instead, if I insert this, I notice that yellow's on bottom. So when I undo it, yellow's going to be back on bottom. I have yellow right here, so I can make it so yellow's on bottom here by doing this. So when I do this commutator, I then would undo, and I would undo my setup move. So that really becomes C, A, B, A prime, B prime, C prime is essentially what that ends up becoming, is when you do a setup move like that. That is basic Heise tutorial I can think of. I hope it was helpful. Goodbye.